Hey guys, welcome back to my YouTube channel. So in this one, I am going to start. I'm not going to. This is not a problem discussion lecture. So I am going to start with this one. So after that, we will be seeing the logic gates, like two level logic gates. So far, we have seen one level logic gates to detail, right? So similarly, I will be discussing about two level logic gates and then some kind of other advanced topics. So I am leaving this to you. So please pause the video and try to answer. So what all are the possible outcomes for y will be happening based upon the parameter n, which is dynamic, right? So I am giving you clue. Consider the scenario when n which is equal to odd and n which is equal to even. So I have clearly already seen in I think 2 lectures back. So how the XOR gate input output will be output will change based upon the number of ones present and number of inputs are there. So please pause the video and try to answer it. So but here I am trying to answer it. So let's see the scenario. So here I can clearly say there is 3 XOR. So 3 XOR gate including this one. So if we have to include means there is 3 XOR gate here. So there is 3. This is completely separate, which is n times. So the total is n plus 3. So this is what the clue that we got. So we are related this with a n. So n plus 3. So let's take a two scenario when n which is equal to odd number means odd number of output. For example, it may be 2 or 3 anything. So if we add odd number plus odd number, then the output will be even number. So this is one case. Then n which is equal to even. So if we add even number to the odd number, then we will again get a odd number. So this is one. So I have clearly said when the total entries which is equal to odd, then the output y will also be equal to one of the element that is present here, that is b. Means the output is remains unchanged. The output will be same as b, that is input that we have. So that is remains unchanged. So but the converse, like when the total is equal to even, definitely the output will be going to be 0. So this is the two scenarios that I have to mention here. So based upon the input that we are using here, right? So that is impacting the output. So here this is seems to be a different. So that is what the XOR gate which has one of the special function. So this is an XOR gate. So which is a special function gate. So this is why they are mentioning this as a special function gate. So I hope this is understood for you guys. So please understand this carefully. If you guys have even any doubt, please post in the comment section, because without this understanding, you can't be able to be good in XOR and XNOR relationship. Because this one, I think many of the guys may already seen these kind of questions in your college examinations also. If you haven't, please make a note of it. This is one of the very good question. So let's get into a logic system. So which is next level of understanding. So where we so far dealt with only single logic gates. So now we are going to start with two level logics. So ultimately we are going to start with two levels. Two levels of gate that are present. So we are going to concatenate both the result. So let's take a logic of NAND and NAND logic. Okay. So here let's have two input NAND gate. Here let's have another one 2 input NAND gate. So since this is a two level logic gate, so we are going to combine both the result. So this is A, B, C, D. And here we are going to again given this to another one 2 input logic gate. So here this can also be equivalently written like this one. So let's push this bubble to outer side. So instead of making the whole bar, even we can make this bubble to push here. So like here the results will come, right? So let me make it that more simple. So this gate won't be changed. This gate is also won't be changed. But thing is that we have pushed the bubbles to the side. So we are pushing this bubble to this side. So if we push this bubble to here, so we have to do two things. So one is to change the gate functionality. So that will be changed from AND to OR gate. So that is one. And the inputs will be need to be complicated. So that is why we added bubbles here. So if we are done to this. So if this is done, this can also be written like this. So these bubbles can be cancelled. This bubble, this bubble, this bubble, this bubble can be cancelled. So then the thing, how the output will look like is, it's a normal AND gate. It's a normal 2 input AND gate, and which is connected to an OR gate. Okay. So here the both output will be same. So A, B, C, D. What will be the output is the A, B plus B, C. Here will also be same. A, B the whole bar, C, D the whole bar. Here what will happen? A, B whole bar, the bar. So then what will happen? Our input will be a plus b, c plus d. Okay, so that's I made a mistake here. It's not a cd, it's a bd plus cd. Okay, here you see we obtain the same logic. The output is same in both the case, but here with some kind of universal logic, here with the basic logic. So sometimes the universal logic will be quite complicated, the IC fabrication will be quite complex. So in this case we can even use the simple logics. So that is what the background idea here. So whenever there is a bubble, then the logic system building will be quite difficult, but without bubbles we can easily build it. So what we have found is that the NAND-NAND two level logic can be now written in and or. Okay, so NAND-NAND logic can be written in and hyphen or. So which is one of the very important thing that you have to note. So similarly, another one, NOR gate is there, right? So NOR gate can be written as or and. So this one you can try it as a homework. The same thing like how we had done previously, just to push the bubbles, change the gate, and then you can able to achieve it. So this is the second observation that you can do. So next, another one gate level logic is the NAND and NOR. So how this can be changed as this can be changed to and or and. So the thing is that when we use the same gate, so NAND and an OR, which is different gate, when we use the same gate, then output will be of two different gates. That is with the starting one. In previous case, if you see NAND and NAND same gate, so two different gate will come and OR. So you can keep note of it for remembering purpose. I am saying. So here OR NOR coming. So here OR plus NAND and so NAND and NOR two different gate. So here will be single gate only. That is AND. So now say what will come here. So NOR plus NAND. So here you can see two different gate. So means the output will be single gate with the starting one. So means R hyphen R. So this is the shortcut that you can remember. So how we can make of implementation like this. So these are some quite tricks that you can use whenever we are trying to solve any problems. So that will help you in most of the cases to make how we can simply make connecting of those things. So I hope this is understood for you guys. So another one table also I'm trying to give here, that is the gate and minimum gate requirement. So this is the gate and minimum two input and minimum two input NOR gate required. So here the not. So please remember this logic: not and or, then XOR XNOR. So here what I'm going to say is that in order to build these logics, how many minimum two input NAND gate and NOR gate are required to make this? So we know that only one gate is enough to make this. These three things we already done in the studying purpose of NAND and NOR. So this thing I haven't done. Please you guys try it. In next lecture I will try it. So how many two input NAND gate is needed to this? This is 2 and for OR is 3. So please exchange this one. So 2 here and 3 here. Okay, so this is 2 for your remembering purpose I am using. So if you guys able to do it and understand, then I am very good that you are going in a good track. So 3 plus 2. So here how many two input NAND gate is required to build OR gate is 4, and 5 input to 5 two input NAND gate is required to build NOR. So if we exchange this one, then this will be 5 and 4. Okay, so thing is that 1 2 3 4 and exchange individually. So you have to remember this logic: NAT and OR XOR and XNOR. So that is very important. Okay, so the next thing that we are going to discuss is the hazards, not environmental hazards. So hazards in a logic gate. The same thing, the logic gate with the delay. So the logic gate with the delay. So delay in a logic gate is a very crucial parameter that we have to address. So this is one of the very confusing term. Many guys will not understand properly. So I will make you to understand very properly. So in this lecture we just see definition, and next lecture we will be seeing the more problems and discussion on this. So hazard is a condition where output changes more than once. So output changes more than once for single input change. More than once for single change in input. Okay, I hope it is understood for you guys. So there is two types of hazards generally there. So one is static hazard and another one is dynamic asset. So static and dynamic. So each thing has its own individual explanation. So let me make it simple. In static asset, when the logic is changes from 0, if initially it was in 0 and changes to 1 and then back to 0, then this is called as a static 0 asset. So the output is static, right? So static 0 asset. So if output is initially 1, that is changed to 0 and then immediately changed to 1, then that is static 1 asset. So here the thing what I am saying to represent, initially the output is 0, but when there is a change in input, that asset is immediately changing to 1 and then back to 1 without a, but the input change is just 1. So only one input change, only one input change. So try to understand it carefully. For single input change, there is two output change. So that is what we are trying to explain here. So with the example that you guys able to understand, for now please note the explanation. So in dynamic asset will occur when the output is changing from 0 to 1 or 1 to 0. But if the output change is more than 1 for single change in output, then we call this as a some kind of dynamic assets. So it may resemble like the static, but here the thing is that we are having not making any particular combination here. In both the static and dynamic asset, the out is affected for a momentum, but it's not permanently. In steady state output, the same thing will be desired. In capacitor, we see right some transient effect. So similar to that, here we are observing some transient cases that we are making as output with some assets. So dynamic asset can occur in combinational circuit. So mostly in combinational circuit we can observe it. So in the next lectures or upcoming lectures, we will start with combinational circuit. So there you guys can understand it carefully. So for now, just note the definition for the term hazard. What is mean by hazard or some kind of thing. Okay. So in the next lecture, we will be starting more with the things like how to solve the problems and everything. So like, share and subscribe. Stay tuned for more lectures like this.